All right, let's look at temperature and heat. In everyday conversation, we might interchange the terms temperature and heat, but in physics, they are very specific things. They don't even have the same units. So temperature, for instance, is at a molecular level is the sum of all the average kinetic energies of the molecules that make up the substance. Now, temperature is measured in Kelvin, and that's the SI unit, so capital K, that's SI unit. It can be measured in Celsius degrees, so Celsius degrees, or in Fahrenheit degrees. Rankine, there's another scale of temperatures. And we need to know how to convert from one of these scales to another. So for instance, 0 degrees Celsius corresponds to 273.15 Kelvin. So this is the conversion between Celsius and Kelvin. So we can say that temperature Kelvin is temperature Celsius plus 273.15. To convert between Celsius and Fahrenheit, Celsius temperature is 5/9 of the Fahrenheit temperature minus 32 degrees. And going back the other way, Fahrenheit is 9/5 Celsius plus 32. Note that only this first example has a parenthesis. There is no parenthesis in this conversion. So we like to use the Kelvin scale, that's the SI unit. Sometimes it's more convenient to use the Celsius scale, and those cases are when an equation has a delta T in it. So for an equation with delta T, one can use either Kelvin or Celsius. In an equation with just a T, one has to absolutely use Kelvin. So that is the SI unit that needs to be used. So it's just arithmetic why we can use either Kelvin or Celsius when we have a delta T in the equation. We add 273.15 and then we subtract it back. So that's why we can use that. If in doubt, use Kelvin. Always convert to Kelvin. All right, so that's temperature. Now, heat is a form of energy. So what that means is that heat is measured in joules. And heat is energy that flows from an object with a high temperature to an object with a low temperature. So heat is energy that flows from high temperature to low temperature. And not the other way around. Now, if we heat an object, so if we change its temperature, then that object might expand. So we can talk of linear thermal expansion. So I'm making the difference between linear and volume thermal expansion. And that means that I'm going to look at a one-dimensional system. So let's say that we have just a very long, thin rod that has originally a length L0, And then we will heat it up so it will expand to some final length. Let's call this difference delta L. So delta L then will be equal to alpha L naught delta T. Alpha is the coefficient of linear expansion. And it has to do with the material that the object is made out of. So we're heating a thin rod up from an initial temperature to some final temperature. It has an initial length, and depending on the material that this object is made of, its length changes by delta L. Now, if we want to look at volume thermal expansion, so now we have a certain volume that we're changing the temperature for, then the change in volume will be beta V naught delta T. So in this equation, delta V is the change in volume, beta is the coefficient of volume expansion, and V naught then is the original volume of the object, delta T is the change in temperature. Now a counterintuitive thing here is that there's a relationship between beta and alpha, between the coefficient of volume expansion and the coefficient of linear expansion. And that relationship is beta is 3 alpha. So that's a little bit strange to think about, but it is true. All right. Now let's see how heat changes with a change in temperature. So we can talk about heat gained or lost with temperature change. And the symbol for heat is Q. So Q is mc delta T. So if the final temperature is higher than the initial temperature, then heat is gained. If the final temperature is lower than the initial temperature, then heat is lost. So in this equation, m is the mass of the object, c is a specific heat, and delta T is a change in temperature. Now, it is possible for heat to be gained or lost, but not with a temperature change. We call that latent heat. So heat gained or lost during a phase change. And that would be Q equals m times L. So m is the mass of the substance, L is latent heat. Now, what is a phase change? So the phase changes are when a substance goes from a solid to a liquid, or the other way around, from liquid to solid. So let's put an arrow in both directions. from solid to gas and the other way around, or from liquid to gas and the other way around. So in all of these different cases, there are different values for the latent heat. So L is going to be different for different substances during these different processes. If we have latent heat of vaporization or condensation or fusion or sublimation, those will all have different values.